The reason I tell that story is that Langway is quoted in there as saying this is basically ice from the time that Christ died.
This is the Discovery Files podcast from the U.S. National Science Foundation. I'm Nate Potker. During the Cold War, a U.S. military installation was carved out of the ice sheet in Greenland. This base, known as Camp Century, was powered by a small nuclear reactor and housed over 100 soldiers, scientists, and engineers. The base was abandoned in 1966 after many secretive missions, at least one of which would not be out of place in a James Bond film. But one of these missions resulted in a near mile-long ice core. In the subsequent decades, that core went missing. We are joined by Paul Bierman, a geologist and professor at the Rubenstein School of the Environment and Gund Institute for Environment at the University of Vermont. Professor Bierman, thank you so much for joining us today.
Thanks for having me.
So what is or was Camp Century?
Camp Century was what at the time was called the City Under the Ice. It was a military base built by the U.S. Army and the Army Corps of Engineers starting in 1959. It was a series of open trenches that were cut into the snow at the top of the Greenland ice sheet, about 135 miles from the coast and the big base at Thule. Those trenches were then roofed and snow was blown over them. So essentially you had a city, as the title was, underneath the ice that could hold between 100 and 200 men. It had a nuclear power reactor that supplied its energy for several years. It had science trenches. It had dining halls. It had latrines. It had bunks. The people there all lived in buildings heated by radiant floor heat to 70 degrees. While they were working in places where it was minus 50 above the surface. So it allowed the military a presence in Greenland at a time when it was strategically really important.
Right. And can you tell me a little bit about what kind of experiments they were working on at the time?
Sure. They were working on all sorts of things. It was a combination of a military base and a science base, mostly with military applications. So some of the crazier things were they were detonating explosives in the snow and under in the tunnels to see what happened. Of course, you might imagine why in the middle of the Cold War they'd be worried about explosives. They built a rail line, very short, less than a mile underneath the ice sheet, and they tested the ability to run rail cars under the ice. That was associated with something known as Project Iceworm, which was the idea that we were going to station multiple nuclear-equipped missiles under the ice in thousands of kilometers worth of tunnels, and they could scoot around, and the Russians would have no idea where the missiles were. And they would pop up and launch. That never came to be. And in fact, probably more web fantasy than it is. It's reality, but it was not the big part of having the base there. Science experiments, they looked a lot at the deformation of snow and ice. In fact, that's what doomed Camp Century in the end, is that the ice sheet is a dynamic place. The snow and ice were moving, the tunnels were collapsing, the roofs were coming in, and they had to shave and shave and shave the inside of the base over the 6 years that it was running and shove all that snow to the outside. They did early experiments in micrometeorites that fell from the sky. They looked at radioactive fallout from nuclear weapons tests, both American tests and then Russian tests, which were much closer, only a couple thousand kilometers away. And they actually studied one of the most fascinating and important studies there. It was done by a guy named Claire Patterson. And he is the one man probably most responsible for removing lead from gasoline. And he went to Camp Century in a complete fit of analytical chemistry paranoia, is the best way to put it, and tried to sample the modern snow and the old ice to figure out what the background levels of lead were. And to do this, that the stories are just amazing of what this man went through, driving out on a place in the ice sheet where no one had been before, walking upwind, going in the tunnels in Camp Century and digging the snow back, because the problem was that the men there were highly contaminated with lead. They were drinking soda out of leaded cans. And you might imagine what they would do in the walls of the tunnels. So he had to be really careful because the urine of the men there, he said, contained 1 million times more lead than snow. So one of the big things that came out of looking at the ice and snow from Camp Century was there was no lead in the old stuff. And so we really could attribute that lead to human action. So lots of interesting science happened, and probably the most long-lasting, impactful science that there was an ice core that was drilled, and it was not the first ice core. At least the first U.S. ice core was 1950 in Alaska, but this was the first ice core to ever penetrate an ice sheet and get to the bottom. Not only did it get to the bottom, it brought up about 3.5 meters of frozen sediment below the ice. That was a first then. That is still a first now to have done that. And so that's how we got into this whole project, because of that sediment. And that ice core revolutionized how people thought about climate. The ice above that, for the first time, told us that over the last 100,000 years, we have swung from a warm interglacial period like we are now to a frigid glacial period on ice sheets covered much of Europe and North America back to warmth. It was the first isotopic record of that heating and cooling. So really revolutionary place in the way that it changed how we think about ice sheets.
So thinking about the cores and what they were learning about the environment at the time, did they take away that that understanding of the way time has passed at that juncture from that original study?
Sure. So the last pieces of the Camp Century ice core came out, this is legend, and I don't know whether it's actually true, on July 4th of 1966, right? So you have to put in context that this is an American ice core drilled by the military. It comes out of the hole in 1966. It travels back to the U.S. And kept frozen the whole time, of course. And its next appearance is in mid-September in the Pentagon. And really fun story with this. My first historical jump into the research here actually occurred on eBay when I Googled the name Chet Langway. And Chet was the man who was really responsible in many ways for the public side of this ice core. He was an ice core scientist. He started ice coring in 1956. He didn't actually do the drilling, but was very much, I think, the coordinator of all this. I Googled Langway and I get an eBay thing saying, photograph Chet Langway, and it looks like he's holding a piece of ice. And so I thought, okay, I've never bought anything on eBay. I'm going to spend $99 and get this photo. It was a press photo. It was an 8x10 color glossy. And it showed up in the mail, and I looked at it. A funny clipping on the back, quite yellowed, and pasted to this photo. And I sort of set it aside and wondered what it was and why this guy was holding an ice core dressed in a tie, narrow tie, the narrow lapel blazers of the 60s. And it was dated, I think, September 22nd, 1966. And a couple of weeks later, I got curious and I started putting that into the New York Times, their time machine for how you go back there. Well, it turns out that Langway and Hansen, who was the head driller, had gone to the Pentagon carrying the ice cores for a show and tell with presumably the Pentagon brass, who had also paid a lot for this core. And they took pieces of the ice, ostensibly from the ice core, and they dropped them in Coca-Cola. And when the ice melts in Coca-Cola, the bubbles from the ancient air and the ice go kind of snap, crackle, pop. And they did this demo, and it's a very tongue-in-cheek New York Times article that says, well, the Coke tasted like Coke and the ice tasted like ice. The reason I tell that story is that Langway is quoted in there as saying this is basically ice from the time that Christ died. So they had some very rough idea at the point of timescales, but really they didn't know. There were speculations that the ice could go back 1 million years. There were speculations that the ice might go back 10,000 years. And it took 3 more years before a paper came out in 1969. That's the first paper. So there's a long delay. And Danish scientists at the time, 2 of them, had modeled the flow of the ice there, counted the layers at the top, and could come up with a preliminary timescale for how old this was. And they had analyzed over 1,600 samples for stable oxygen isotopes in the water molecules that made up the ice. That oxygen isotope measurements gave them the climate record. The modeling gave them the age and dating. And together they put that and compared it to the existing records of the comings and goings of glaciers in Europe. And that was the beginning of very deep European involvement with the analysis of this ice core and ice cores to follow. So it took a couple years before the idea of deep ice time became clear. And then it never stopped. That was a revolutionary moment when we had a stratigraphic, a layered record that could take us back 100,000 years.
Right.
And another couple decades passed, and now we have 800,000 years of stratigraphic record from Antarctica. But this was the start. And a small aside to that is the drill that successfully got the ice out of Camp Century was packed up, shipped to Antarctica, sent to Baird Station, and got the second ice core that went to the bottom of an ice sheet. And then they lost it. It frozen at the bottom.
Ugh.
That was the end of the U.S. drilling program for a long time because the best drill was sitting at the bottom of the Antarctic ice sheet.
Oof. and quite expensive to get those things together. We've talked to a couple people that did more recent drilling down there, and
Absolutely.
it's a bit of a challenge for them. So somewhere in between, the core sample goes missing. So
Yes.
where was it found, and how did you get involved with the story?
Sure. So the core makes a big, a big scientific splash in 1969 when this paper comes out, and then a whole series of papers come out in the next decade. But interestingly enough, the first paper about the material at the bottom, that 3.5 meters of frozen glacial sediment, the first paper for that doesn't come out till 1980. And then one comes out in 81, and then one comes out in 86. So we are working now not on the ice, but on that 3.5 meters of sediment. And yet, despite being the only collection of this material that's really happened like that, and happening in 1966, it's basically ignored. And then things go quiet. And the history of the core is that it went first to CREL, which is the Cold Regions Research and Engineering Laboratory in New Hampshire. And it stayed there with Chet Langway until he moved on to the Department of Geology at the University at Buffalo. And the National Science Foundation at that point started funding Langway to have the National Core Repository. And that was at Buffalo. They kept funding him for nearly 20 years. And from talking to National Science Foundation program managers at the time, there was really a feel in the U.S. that they, by the late 80s and early 90s, wanted to build a U.S. expertise in ice core analysis. And they wanted the National Repository to be open to anybody who wanted to use that ice for science that they had funded. From talking both to the Danes and the U.S. community, at some point in the mid-90s, between 1994 and 1996, the bottom part of the Camp Century core went missing. So the upper part, the ice, actually there were 3 cores. The ice from all 3 cores went to Colorado. But I believe it was about the bottom 131 meters of Camp Century didn't make it to Colorado. And at that point, nobody really knew where it was. There were rumors it was in Denmark. And all of us who knew about Camp Century sort of said, this stuff must be somewhere, but hopefully it's not, out back. And in 2018, I was at a meeting about the Greenland ice sheet in Buffalo, of all places. And Dorte Dahl Jensen and I, who's essentially the queen of Danish ice core science, one of the first women to be deeply involved in ice core science, which is something we could come back to because the entire effort in the 50s and 60s was 100% male because of the military involvement and the times. And now, of course, things are very different in glaciological work. But Dorte and I were sitting at a table together. We're similar age. I think a picnic table outside waiting for a little group that we were going to discuss. And she said, Paul, we have more bottoms of cores in Copenhagen. You should come sometime and have a look at them. And I said, I'd love to come and have a look at them. Ding, exactly. And Dorte and I are both really busy. And I actually was in Copenhagen about 6 months later, and I texted her and she wasn't in town and we just never connected. And then out of the blue in 2019, I got an email saying, Paul, do you want to come to Copenhagen in 2 weeks? We're going to have a very small meeting of people to look at all the bottoms of ice cores. And so I immediately bought a plane ticket to Copenhagen, and I asked my teaching fellows to take over my class for a couple of days. And I got on a plane and went to Copenhagen. And there were, I think, 10 or 12 of us at the meeting. And we each had 5 or 10 minutes to present what we knew about Greenland and the old ice. And Dorte and then JP, who is the other very important Danish ice core person who runs their ice core repository, got up and basically told us the story that as they were opening a brand new ice core facility in Copenhagen, it's a beautiful, beautiful building, cooled by carbon dioxide. There's some irony to that. That's their refrigerant gas. They pulled together ice cores that they had stored all over the city in rented facilities, all into this, purpose-built, state-of-the-art storage and processing facility. And when they did that, they bumped into 2 boxes, which were labeled Camp Century sub ice. Ice was saved in Denmark. The Danes did an amazing job of preserving it, and the world now has access to it. There's a picture of me holding those with just a huge smile. We're putting our hands on stuff that almost 60 years ago came out of the ice sheet. That, given what I do as a scientist and what I've done with NSF support for the last 30 years, was sort of the penultimate time of my career to actually be holding this stuff and thinking, what can we do scientifically? So that's how it came back into my life, back into in the sense that I've been studying glaciers since the early 1980s as an undergraduate student, and knew of Camp Century, sure, since then. But it opened up a huge window for a bunch of us working on this. So we mentioned to Dorte and JP that if we had one or two samples, it would let us get the data we needed to prove that analysis of this core could work, and that it could really change how we think about the history of the Greenland ice sheet. And we did the fastest ever processing in our laboratory, which measures some very rare isotopes that are formed by cosmic rays. But not only did that, we took the material apart first. And this is probably equally exciting moment in my life, of the top two science moments. It was very hot here. It was middle of July, steamy, humid, and we're working in a nice indoor lab. And we opened up the first bag of this stuff. It was still frozen, to have a look at it. And we got hit in the face with the smell of diesel fuel and organic solvents, because the drilling fluid was a mixture of trichloroethylene, which is dry cleaning fluid, and diesel fuel. So immediately popped it in a fume hood, and we melted the stuff. And an hour or two later, we had a puddle of wet mud. You could hold it in your hand. I mean, it's that small, a couple 100 grams of mud. And we went upstairs to our cleaner labs where we work, and we started rinsing it through a set of sieves to figure out what size the grains were in there, because we need a certain sand size grain to do our chemical analysis. And we're saving everything, every drop of water that goes through it. So we were sieving with water, every bit of sediment. And it was one of those afternoons where I was sort of staring at this bin of wash water. And you know how you just sort of space out sometimes. And I'm just looking at this bin of wash water, and there's things floating in it. And I just had this like tingly feeling, is the only way I can put it, because early in my career, I did a lot of lake coring, and the way we would find fossils in lake sediments was to throw them in a bit of water, stir them around, and see what floated. And I just tapped Drew on the shoulder, and I could barely say anything. And I'm just like, you got to look at this. You know, I think we have fossils in here. And he gave me one of those looks like, you are insane. And they turned on the microscope, and Drew's looking, and he's looking, and he looked up with a gaze that I'll just never forget.
Jaw drops.
The literal jaw drop. And there's a twig, and there's a little leaf. And we spent the rest of the afternoon with pipettes sucking all this little organic material out and putting it in jars. That was the aha moment of this. Not only did we have material from the bottom of the Greenland ice sheet, but we had material that had been in the freezer for who knows how long and was nearly perfectly preserved. And that became that just became the moment that started all this. So what are we going to do next? And the what are we going to do next that came out of that was the NSF proposal that funds us now. And that was a systematic approach to how to take material that is more rare than moon rocks. There are many more kilograms, I think 6 times as many kilograms of moon rocks as there are of this stuff. And so we were treating it that way. We wanted to know where every gram was going to go, how we could do analyses so that they didn't cross-contaminate each other and cause problems. And there are more than 20 different people and institutions on the team that are doing this. So there are samples literally around the world right now. It's been a major effort to look at something collected when I was 5 years old in the middle of the Cold War. So probably the most satisfying science I've done in my life. It feels like the culmination of doing lots of different things, all of which now are being applied at this one, 3.5 meter narrow core of rock and ice.
All right, pretty amazing. Was just finding the fossils the biggest surprise to you?
Well, finding the fossils was the first surprise, right? And there is something special about holding something came out of the bottom of the Greenland ice sheet. But yes, finding the fossils was the biggest surprise, because it meant that we had an ecosystem preserved there, and that had huge implications, right?
Right.
That meant the ice went away. You could not have that ecosystem with an ice sheet on top of there. And we're 130 some odd miles from the coast at an elevation over 7,000 feet. There's a lot of ice there, and it was gone. So then the next question became, when did this go away? Are we seeing back to before the Greenland ice sheet became the Greenland ice sheet? Are we seeing back 2.5, 2.6, 2.7 million years? Or during the last big interglacial, the Eemian interglacial 129,000 years ago, did the ice disappear there? The suggestions were that the ice on top of Camp Century was old enough that probably wasn't the case. But could that ice have come in from elsewhere? So the next real focus for us was dating at this point. So we knew we had the ecosystem. We wanted to date when it went away. And our lab is capable of doing that in some ways, although very indirectly. So we measure very rare isotopes of aluminum and beryllium. And we can use those to determine how long something's been buried, how long it's been away from the cosmic ray flux. And the Greenland ice sheet does a pretty good job of burying things, when they're down the better part of a mile underneath there. So we started purifying the quartz, and then we work with the Livermore Laboratory, and we work with Purdue University Prime Lab, which is an NSF-supported facility. And we did the biggest hurry up I think we've ever accomplished of purifying this quartz, dissolving it, doing 10 days worth of chemistry, packing up cathodes, getting them to these repurposed particle accelerators. And then our colleagues there made measurements. And literally the last data came, I think, 2 days before this meeting in October by a phone call saying, we are at the accelerator. These are your measured ratios right now. And we learned from that the older material has not been re-exposed for about the last 3 million years. That's at the bottom of the core. So we had material potentially back to the dawn of the glaciation in Greenland. Then we started trying to figure out how old the uppermost material was. And the best we could do at the time, based on this ratio of aluminum to beryllium, was less than 1 million years. So we concluded that the ice had left Camp Century less than 1 million years ago, and a tundra-like ecosystem had become established. Because now, for the first time, we had definitive terrestrial evidence in northern Greenland that the ice had gone away in the last 1 million years. In southern Greenland, that evidence had come earlier from a core called Dye 3. But in the north, nobody knew. And I've always thought that the southern part of Greenland was much more vulnerable to melting. But now we had this evidence that the north was vulnerable.
Right. One of those things that sort of changes what you know about what you know.
Exactly. Or what you know about what you didn't know.
Right.
And so we've got that evidence. Sea levels 400,000 years ago were much higher than today. So now we had an age on the top material. And we had an age in something called marine isotope stage 11, which is that warm period. That fit really well with our understanding of sea level rise in the past and warm climates in the past. The trick is that at 400,000 years ago, global carbon dioxide was close to 300 parts per million in the atmosphere. Today, we're at 422. So we are pushing the climate system to warm even more aggressively than nature did 400,000 years ago. That was capable of removing the ice from northwestern Greenland. I think what follows logically from that is as we crank up carbon dioxide, the ice is going to leave northwest Greenland. The time scale on that, centuries at least. But I think that's what attracted the interest in the science is all of a sudden we knew that nature was capable of removing the ice at far less pressure than we're putting on the climate system right now.
Right. So can we talk a little bit about how does the ice sheet interact with the ecosystem there in Greenland?
Sure. Well, its last interaction with the ecosystem was to put it in the freezer. So the ice sheet became reestablished on top of this sediment that we have measured. And the sediment was frozen then, it's frozen now. Was there a period where the sediment was melted? Absolutely, in there. Could there have been more material that's now been eroded away from the ice? Absolutely. We don't know that. But what we do know is there was an ecosystem there at the time that looked a lot like modern day Greenland tundra at the edge of the ice sheet. So it has mostly shrubby things, little bits of perhaps willow, birch. There are small insects that are indicative of the Arctic like that. All the kind of plants you would expect if you wandered around that part of the world now and would kind of scratch you below the knees as you went through there. And the little midges that, would fly around your face. They're all in there. Today, the influence of Greenland is far more worldwide. All right. So the ice sheet itself, you can think about as a big reflector. And the sunlight that comes in and hits the ice sheet, especially if the snow remains cold and dry, most of it bounces off and goes right back to space. As the Greenland ice sheet starts to melt, the snow and ice on it become gray and darker. They absorb more sunlight. And then once the ice is gone, you have very little reflection of sunlight. Most of it's absorbed by the dark rock. And if the forests come back to Greenland, absorbed by the forest. So Greenland is worldwide helping to control climate, therefore helping to control ecosystems very far away from Camp Century. And of course, the other influence it has is Greenland holds meters of sea level, up to 7 meters of sea level. If you melt the ice sheet, that water goes somewhere. It goes into the global ocean. And if you raise sea level 7 meters, 25 feet, think about Boston, New York, much of the country of Bangladesh, the Pacific Islands. So ecosystems everywhere are going to be underwater. So there's a real connection, I think, between this fossil ecosystem under the ice and the results of what's going to happen if we continue to warm Earth's climate and the Greenland ice sheet does indeed melt.
Special thanks to Paul Bierman. For the Discovery Files, I'm Nate Potker. Discover how the U.S. National Science Foundation is advancing research at nsf.gov.